Alright, you guys, so here's another way we can solve an equation. You'll notice what's different about these equations as opposed to the ones we just did is we're not set equal to 0. Alright, so the x-intercept idea, there's the third equation, right? We actually have an equation equal to an equation. Here we have an equation equal to an equation and so forth and so on. So you have a couple of things you can go on. You can use idea number 2 like I'm going to share with you. Or, like in this case, we could probably subtract 12 from both sides and rewrite this as absolute value of x squared minus 4x minus 12 equals 0, and you're back to idea number 2, or number 1, where we take advantage of the x-intercept. Same thing here, right? Move that all over and set it equal to 0 down there at the bottom. So you have a couple of ways to do it, but since we're learning this second idea, let me keep things the way they are. So here's the theory behind this, right? If this obviously is a line, let me call it y1, and this is also a line y2. So the theory is if I come over here to graph, right, this y-intercept at 0, -3, and the slope's a half. So that line looks like that, right? So there's y1. And then it's being equal to another line that has an intercept at 5, but a negative slope, so it's running something like that. And so there's y2. So what we're trying to find is what inputs make this output and this output the same. Well, what we're looking for is an intersection point, a point of intersection. Now, it's just coincidence that that looks like it's also an x-intercept for these graphs, and that's purely coincidence. It may or may not be, but what it is, it's a point of intersection. Same thing down here, right? Here we have an absolute value, so that absolute value graph is going to probably look v-ish, and then y equals to 12, right? Well, that's a horizontal line. And so again, we're looking for when do those two lines intersect. And then last but not least down here, we definitely have a parabola and we have a line with a positive slope. So if I graph those two things again, we're looking at where they intersect. So that's the other idea on how to get the graphing calculator, right, in play to solve equations. Basically, input two functions and look at the intersection points. So let's see how do we do this. There's the theory behind it, the algebra behind the idea. Now let's go press some buttons. So again, let's make sure my window is in standard viewing rectangle. All right, let's do that first since I did some previous work. Let me go to y equals and clear that guy out. And what I need to do first is put 1/2 x minus 3. Again, I'm a parentheses guy. So 1 divided by 2 times x, right, minus 3. There's the first line. Press enter. So now it's loaded into the calculator. The next one, again, parentheses, -3 divided by 4, x, and then plus 5. And press enter. So I've locked both of them into the calculator. I'm going to go graph. There's the first line, right, 1/2 x minus 3. And there's the next line, right, 1/2 x, or excuse me, -3/4 x plus 5. So the point of interest, right, does look like it's really close to the x-axis. So how do we find that point of intersection? Well, again, you're going to open up the calculate menu, second, calculate, and rather than finding a 0 this time, what we are now doing is trying to find an intersection point. So item number 5. So I'm going to press enter, and just like the other one, right, it's going to ask us some questions. So you'll notice that what it's on right now is my cursor is on the first curve. So what you want to do, right, at y1, is move your cursor as close to that intersection point as you can, because we're going to try to give the graphing calculator somewhat of an estimate of where that intersection point is. So how about I just say right there. Now, when you press enter, what happens next is the cursor actually jump from the first curve to the second curve. So notice if I start moving left to right, notice I'm now tracing right along that second curve. But it's basically asking the same thing. So along that second curve, right, what do you estimate, right, the intersection to be? So it looks about right there. We'll press enter. And then it's asking for a guess. What I just do, rather than messing around with the cursor, I just press enter yet again. And then what it pops out after all that button pressing is our intersection point. So it looks like our intersection point's occurring. X is equal to, right, nice 6.4, and y is equal to 0.2. But there's basically your solution to that equation. So what value of x solves the equation? 6.4. What's the value of both of these function at 6.4? It's 0.2. But the algebra, if we were to solve this linear equation, the algebra, we would get that answer, and it'd probably be in fractional form, right? It'd be something like 6 2/5 or something of that nature. So algebra versus that. And that's basically how you do that. All right, so there's your introduction. I'm already 5 minutes into this, and I'm a little bit afraid that I'm going to run out of time in terms of data. So let me go ahead and show you that intersection idea with the next two, right, in a nice fresh video. So I'll come at you in another video.